Stoichiometry. Can anyone elaborate the meaning of stoichiometry? What is meant by stoichiometry? Or what is meant by stoichiometric coefficients? Anyone? Okay, I'll give the meaning of stoichiometry. Please make a note of it. Knowing the mass relations, knowing the mass relations, Knowing, knowing the mass relations among various substances, in a net balanced equation. In a net balanced equation is known as stoichiometry. So what is stoichiometry? It is knowing what we have to know. The mass relations. Mass relations between whom? Among various substances in a net balanced equation. Suppose I ask you one more question here. An equation is balanced. An equation is balanced according to which law? A chemical equation is balanced according to which law? Yes.
Law of conservation.
Very good. Law of conservation of mass. So according to law of conservation of mass, an equation should be balanced. Because the total mass of the products is always equal to the total mass of the reactants. But for what kind of reactions, law of conservation of mass do not hold good? For what kind of reactions, law of conservation of mass is not applicable? The answer is for nuclear reactions. Because in nuclear reactions, mass is not conserved. Mass destroys. That destroyed mass is converted into energy. So for all chemical reactions, the balancing is based on law of conservation of mass proposed by Lavoisier, a French lawyer. Very interesting point. He is a lawyer by profession, Lavoisier. But we call him as father of modern chemistry. So how a lawyer become that much famous? Very simple. Lavoisier from the beginning of his childhood is more interested in experiments. He is from an affluent family. Lot of money is there. That's why he used to purchase chemicals and do experiments in his own house. And whatever the experiments he did or he conducted, he used to record them in a proper way. So all the results are properly recorded. That's why most of the discoveries in chemistry, in the beginning of the chemistry, are by Lavoisier. So that's why he is considered to be the father of modern chemistry. So he proposed law of conservation of mass by observing the total mass of the products in a chemical reaction is always equal to the total mass of the reactants. For chemical reactions, law of conservation of mass is applicable. For what reactions law of conservation of mass is not applicable? Nuclear reactions. For nuclear reactions, it is not applicable. Next. Now, to know the mass relations among different substances, in a chemical reaction is called stoichiometry. The stoichiometric equations, the stoichiometric equations can be classified can be classified into, I write the first one, only half part is function. Okay, the first one here I am writing. Mass relation. The second one, you can say mass volume relation. The third one, volume relations. Fourth one, mass mole relation. Fifth one, volume mole relations. And the sixth one, mole relations. So the balance for all these relations, students should know the balanced equations. So here I write some balanced equations. So I take one more new one. Down this one.
What's the new one?
See that the entire board functions.
Okay, sir. This one's to add this one.
Which one?
This one to add, this one to minus, sir, the page.
Oh.
And because of the shadow you can't write, sir. You have to give.
So in mass relation, if you look at decomposition reactions, students mainly fail here. They don't know the balanced decomposition reactions. That's why they can't solve the problem. For example, if I ask you, what are the decomposition products of potassium chlorate, KClO3? Can anyone? No. That's why you have to know a set of decomposition reactions. So this is the decomposition of potassium chlorate. 2 KClO3 solid on heating, 2 KCl solid plus 3 O2 gas. This is one decomposition. 2 KNO3 potassium nitrate
Plus
2 KNO2 plus O2. Two NaN3 solid. 2 Na plus 3 N2 gas. What is the name of NaN3? Sodium azide. Sodium azide. I'll give one more. BaN3 twice. Barium azide. Arrow delta. Delta means heating. Decompositions require heating. So barium plus nitrogen. Gas you can also write arrow upwards. Lithium carbonate. Lithium oxide plus carbon dioxide. Now third and fourth. Third and fourth. We use in a particular application. Can any one of you tell? Sodium azide or barium azide on decomposition, liberating nitrogen gas, we use in a very important application. It is also a life-saving application. Yes, anyone? Car airbags. The modern car airbags. So whenever car hits any other car, opposing car, it is a head-on collision, or the car collides a road divider or a tree or an electrical pole. If the impact of the collision is very high, immediately the sensors in the front part of the car, they notice it. Immediately send an electrical signal to the airbag, which immediately produces a spark. The spark in the bag decomposes sodium azide or barium azide. Immediately within no time, as the car collides, the sensor sends the impact of the collision, send an electrical signal, which send a spark. Immediately the bag opens. When bag opens, before you and the hard parts of the car, it acts as a cushioning material. The purpose of car airbag is to act as a cushion and prevent you from crushing to death. So that much mechanism is involved in the car airbags. Once the bag is opened, it won't again function. You have to give it to the car showroom or the workshop, where they will replace with another bag by charging some amount. Now I wrote the decomposition of lithium carbonate, reaction number 5. Now 6, 7, 8. Here I mention sodium carbonate, potassium carbonate, rubidium carbonate, and 9th and 10th also. Again, so after lithium carbonate, sodium carbonate, potassium carbonate, rubidium carbonate, cesium carbonate. All these are heated. What are the decomposition products? Anyone? So all first group carbonates, lithium, sodium, potassium, rubidium, cesium are first group. First group carbonates, in the earlier slide we have shown the decomposition of lithium carbonate. But what about other carbonates? Other carbonates on heating, no action. Means they don't decompose. They don't decompose. They are thermally stable. So among the first group carbonates, which carbonate is only decomposing? Lithium carbonate. And it is similar to the decomposition of magnesium carbonate, which is a diagonal relation. In periodic table, lithium and magnesium are diagonally related. So one of the best examples that lithium and magnesium are related in some chemical properties, that both lithium carbonate and magnesium carbonate decompose on heating, giving carbon dioxide. But other first group carbonates are stable. Now write the decomposition of hydrogen peroxide. Write the decomposition of ozone. Write the decomposition of potassium permanganate. Write the decomposition of potassium dichromate. Write the decomposition of lead nitrate. Write the decomposition of silver nitrate. Yes. Now if you see the products, 2H2O2 is a liquid. 2H2O liquid plus O2 gas. What is decomposition of ozone? 2O3 gas, 3O2 gas. Suppose I ask you a thermodynamic question here. In the decomposition of ozone, what happens to the entropy? In the decomposition of ozone, the entropy change, delta S, Option 1, delta S 0, delta S positive, delta S negative, can't be predicted. So what is your answer?
That's it.
Entropy is a measure of randomness or disorderness. Left side, number of moles of ozone are 2 moles. Right side, how many moles?
29.
3 moles. Means number of moles of gases are increasing left to right.
3%.
When number of moles of gases are increasing, the randomness increase, the entropy increase. Delta S is positive for this reaction.
What's that?
Right there. Delta S is equal to positive.
Good question.
Now what happens to delta G? And what happens to delta H? So delta H, delta S, delta G. Change in enthalpy, change in entropy, change in free energy. Now just now I gave delta S is positive. Now formation of the reverse. 3O2 gives 2O3. Delta H is equal to plus 50 So formation of ozone from oxygen, is it endo or exo? Quick, everything is on the board. Formation of ozone from oxygen. What, professor? Formation of ozone from oxygen, is it exo or endothermic? What happens to delta H? Is it positive or negative? Delta H positive means it is endothermic. Sit down. Now we are considering the reverse reaction. Ozone to oxygen in the given list. When O2 to O3 is delta H positive, O3 to O2 become delta H negative, means exothermic. This is endothermic. This is endothermic. The reverse we consider means this one. Delta H will be delta H is equal to minus 58.2 kilojoules. So ozone decomposition is exothermic. So delta H is equal to negative. So what is the relation between delta G and delta H and delta S? Gibbs-Helmholtz equation. What is Gibbs-Helmholtz equation? In your thermodynamics chapter of your 11th class, delta G is equal to delta H minus T into delta S. Here in this particular equation, delta H is negative minus T into delta S is positive.
Sure.
So overall value delta G become negative. So whenever delta G is negative, Whenever delta G is negative, the process is, whenever delta G is negative, the process is,
reversible,
the process is, whenever delta G is negative,
Spontaneous.
very good, he is right. Your name,
Rudolph. Rudolph.
spelling,
Rudolph. R-U-D-O-L-P-H.
are you?
D.
D.
O-L-P-H.
Oh, Rudolph.
X.
Rudolf Hitler. Hitler's prefix is Rudolf only. So Dr. Rudolf is correct. When delta G is negative, it is spontaneous, not reversible. Some doctor is telling reversible. Which doctor? You are telling them. So, whenever delta G is negative, the process is spontaneous. That's why whenever you keep high concentrations of ozone at room temperature, it spontaneously explodes because it wants to convert into oxygen. Why it wants to convert into oxygen? Because the delta G is becoming negative. Delta H is negative, delta S is positive. All three conditions are favorable for spontaneous processes. For spontaneous process, three conditions. Delta S must be positive, delta H must be negative, delta G must be negative. All three are favorable in the decomposition of ozone. So decomposition of ozone is very spontaneous. So Russians played a chess game. Russians are good at chess. All former world champions, Karpov, Kasparov, the woman world champion Maya Chapardanich. So all are very good chess players. So Russians played a chess game with the German army. When Germans are advancing, they want to retreat from that place. They will remove all the things and run away, back into back. So Russian army is very victorious. They are telling Hitler, whenever we are advancing, nobody is there to oppose. Just we are advancing. Like that, they advance. Meanwhile, the winter sets in Russia. Russian winters are very horrible winters. Except the local people, nobody can survive. The Russians played the same trick. They don't want to fight with the German army. Let German army fight with the climate. So when Germans are deeply advanced, the winter sets in, they can't go back, they can't advance. They are very suffocated with the extreme cold conditions. Then the Russians use it to attack. They can't survive with the temperatures. The opponent is attacking. Ultimately, it is a gross mistake, failure on the part of Hitler that he attacked Russia with a very short plan. And then Russians defeated the Germans, had advanced into the Berlin. And Russian forces, which are called Red Army, so the Red Army forces are advancing into the Berlin. Hitler came to know, no, it is not a wise step. What I have to do, I can't do anything. He shoot himself dead. He committed a suicide. That is a sad end of Hitler. So Hitler actually asked the German scientist to use hydrogen peroxide as a propellant for rockets. Because propellant means that which supplies oxygen to the fuel. See the decomposition of H2O2. 2H2O2 gives 2H2O plus O2. So that O2 is supplied to the fuel. Rocket goes for a long distance. So German scientists, they developed hydrogen fueled rockets and they named it as V2 rockets in World War II. The V2 rockets, Germans successfully used to attack London city, which are propelled by hydrogen peroxide. Now ozone decomposition, though I have shown that 2O3 gives 3O2, but in normal conditions, O3 gives O2 plus O. H2O2 gives H2O plus O. HOCl, hypochlorous acid. So all these you write at one place. They are giving nascent oxygen, newly born oxygen in the brackets is called nascent. Nascent means newly born, just generated. This newly born oxygen by hydrogen peroxide, as would-be doctors, you are using to wash the wounds, the infected part, the infected ears, infected teeth. Doctors use hydrogen peroxide for washing the wounds. It is a sterilizing agent. How H2O2 clean the wounds, or how it stops spreading the infection? Because H2O2, when touch on your skin, your body temperature will decompose H2O2 into H2O plus O. Nascent oxygen kill all bacteria, fungal spores, microbes, everything. Nascent oxygen is very powerful. Suppose Adolf applies some H2O2, hydrogen peroxide, and also with some ammonia to his black hair. He thoroughly applied. After a few minutes, the entire hair become golden yellow. So H2O2 is used as bleaching agent also. It bleaches the black hair into golden yellow color. Some people, fashionable people, they want to create so many different shades for different parts of their hair. So if Adolf wants to convert his black hair to golden yellow color, what he has to apply? A mixture of hydrogen peroxide plus ammonia. Now in some bottled water, you can see ozonized water. Sometimes, next time when you purchase Bisleri or Kingley or any water bottle, you can see ozonized, the word. When ozone is passed into water, it breaks into O2 plus O. That O will kill all the bacteria present in the water. So that's why we call it as ozonized water, which is a sterilizing agent. Here as a repeater batch, as you know the first year, the 11th and 12th portion thoroughly. Here I will ask one more question. Which of the following is used to know the position of double bonds in alkenes? Which of the following is used to know the position of double bonds in alkenes? So here I am creating a question in organic chemistry. Now first option, ozone, O3. Second option, H2O2. Third option, Bayer's reagent, BAYERS, Bayer's reagent. And fourth option, Tollens reagent. Or, okay, Tollens reagent. You are giving the answer?
No, I want to
Number 1 is ozone, O3. Number 2, what I have given? Hydrogen peroxide. Number 3, I have given Bayer's reagent. Number 4, Tollens reagent. So what is your answer? Pakka neat syllabus. Option? First one, excellent. Ozone is the correct answer. Because write a point there. By ozonolysis reaction, by ozonolysis, reaction, we can know the position of double bonds in a given alkene. By ozonolysis reaction, we can know the position of double bonds in alkenes. Now what happens to the Bayer's reagent? What is Bayer's reagent? What is the purpose of it? Yes, any doctor? What is Bayer's reagent? What is the purpose of it? Bayer's reagent is cold dilute alkaline potassium permanganate. What is Bayer's reagent? Cold dilute alkaline KMnO4 potassium permanganate, within brackets pink color. Now this pink colored permanganate in organic chemistry we use for identifying for a particular thing. What is it? The answer is for testing the unsaturation, presence of double bonds or triple bonds. Presence of unsaturation, within brackets double bonds or triple bonds, is known by presence of unsaturation. What is meant by presence of unsaturation? Within brackets presence of double bonds or triple bonds in a carbon chain. Is identified by number 1 Bayer's reagent, number 2 bromine in carbon tetrachloride Br2 in CCl4. So by using only 2 compounds, bromine Br2 in carbons tetrachloride CCl4, that is a medium. So by what reagents you can test unsaturation in a given organic compound? Either Bayer's reagent or bromine in CCl4. So right there, one more small point you add to the existing point. Unsaturated compounds decolorize. Unsaturated compounds decolorize. Both Bayer's reagent and bromine. So test tube, alkene. In another test tube, alkyne. Alkenes contain double bonds. Alkyne contain triple bond. Alkenes have CnH2n minus CnH2n is alkenes. CnH2n minus 2 for alkynes, general formula. So alkenes contain double bonds, alkynes contain triple bonds between carbon and carbon. But in a test tube, if I give an alkene, you can't see double bonds or triple bonds, nothing. Nothing is visible to you.
No.
So that's why if you add some Bayer's reagent, pink colored Bayer's reagent, if the pink color is decolorized, the given compound is unsaturated. But you can't say whether it is alkene or alkyne. It can be alkene or it can be alkyne. Both decolorize. Similarly, bromine is reddish brown color, fuming liquid. What is the color of bromine? Reddish brown. If you add reddish brown bromine into a test tube containing alkene or alkyne, what happens? The reddish brown color is decolorized. Reddish brown color is decolorized. Now here, still we are in the decomposition reactions. What happened to the board? If you don't use it, you will completely go into sleep. What?
Yes, sir.
Okay, good. So here, okay, here I am erasing this part to provide some space for this. Now potassium permanganate, 2 KMnO4, gives rise to K2MnO4 plus MnO2 plus O2. This is the decomposition of potassium permanganate. Potassium dichromate. K2CrO4 plus Cr2O3 plus O2. PbNO3 twice, 2 PbO plus 4 NO2 plus O2. Now in the AgNO3, this reaction, first it gives Ag2O plus NO2. This is the first equation. In the second equation, Ag2O gives Ag plus O2. Two Ag2O, 4 Ag. This we can. Okay, now I'll add one more extra and write again. So AgNO3 decomposition, silver nitrate decomposition. First it gives silver oxide plus nitrogen dioxide. The formed silver oxide again decomposes into silver plus oxygen. To balance this, you write 2Ag2O, 4Ag. Two partial equations we are adding. But when you are adding two partial equations, Ag2O must be cancelled. That's why I am multiplying with 2. Then this 2Ag2O cancels. Then final equation, 2AgNO3 here also 2AgNO3. So here it is 4AgNO3. Four Ag plus 2NO2. Sorry, here 2NO2. So here it should be 4NO2. Plus O2. This is the final equation. Sodium bicarbonate decomposition. Find the number of moles of electrons in 1 mole of azide ion which is N3 minus and 1 mole of nitride ion which is N3 minus. You have to find the number of moles of electrons in 1 mole of azide ion and 1 mole of nitride ion. What is the difference? Nitride ion is N superscript 3 minus. Azide ion is N3 minus. Yes. So what is the answer? Fast. So N3 minus 3 nitrogens, 3 into 7 electrons plus 1 minus 1 electron. That is equal to 22 electrons. One single azide ion contains how many nitrogens? 3 nitrogens. Each nitrogen has how many electrons? 7. So total 21 electrons. It is carrying 1 unit of negative charge. Means 1 extra electron is there. Total how many electrons? 22 electrons in one single ion. If you consider 1 mole, yes, one single ion contains 22 electrons. 1 mole of ions contain quick. Again I repeat, one single N3 minus carries how many electrons? 22. Suppose if 2 ions are there, 2 into 22. If 3 are there, 3 into 22. If 1 mole is there, 1 mole into 22. So 22 moles of electrons will be there. 22 into Na, Avogadro number. So 1 mole hazard ion contain how many electrons? 1 mole of hazard ion contain how many electrons? Dr. Saab, get up. Why you are in sleepy mode?
At night. First.
ज़्यादा पूरी खाया, कम खाया, not at all eaten, normal only. So you do one thing, you go outside, run fast, wash your face and come here by running only.
Here is. I have water.
You have water only? Okay. Be active. So half portion I answered. What is that? 22 moles of electrons. Because one azide ion contains 22. If I ask you 10 azides, 10 into 22. If I ask 1 mole azide, 1 mole into 22. So 22 into Na electrons. Next, nitride ion. Nitride ion, N3 minus. N3 minus. One single M3 minus contain how many electrons? 10 electrons, 7 plus 3. One single nitride ion contains 7 plus 3 minus means 3 electrons. Total 10 electrons in a single ion. If I consider 1 mole into 10 electrons. Correct? One single ion contains 10 electrons. If I ask you 2 ions, 2 into 10 electrons. If I ask 10 ions, 10 into 10 electrons. If I ask you 1 mole of electrons, 1 mole into 10 electrons. That is 6.023 into 10 power 24 electrons. 6.023 into 10 power 23 into 10. Final answer you will get 6.022 into 10 power 24 electrons in 1 mole of nitride ion. So now you came to know the difference between azide and nitride. Azide is 3 nitrogen atoms carrying 1 unit of negative charge. Nitride is 1 nitrogen atom carrying 3 units of negative charge. Next. So far, till now, I have given a list of decomposition reactions, the balanced equations. I think potassium dichromate decomposition, Potassium dichromate decomposition. Oh. How to go to previous page? This one? This one. I think this is not balanced. Even you write 2 Cr2O3. Now oxygens become 14 there. Here 8 plus 6, 14. Oh, no. Then erase this coefficients 2 here. Plus Cr2O3 plus O2. Two K2 Cr2O3, 2 K2 CrO4, chromiums become 4. Now oxygens become 14 there. Here 8 plus 3, 11. 3 more oxygens. 3 by 2 O2 gas. This is balance. Now, write the heading, problems based on decomposition reactions. Problems based on decomposition reactions. Find the weight of CO2 formed. Find the weight of carbon dioxide formed. When 10 grams of limestone 10 grams of limestone is decomposed. Grams of limestone is decomposed. So CaCO3, CaO plus CO2. So as per this equation, 1 mole decomposes to give 1 mole CO2. 1 mole means it is 100 grams. Give 1 mole means 44 grams. 10 gram gives how much? So 10 into 44 by 100, 4.4 grams. This is mass relation. What is this problem? Mass. How it is 100 gram? It is 40 plus 12 plus 48. Calcium is 40, carbon is 12, 3 oxygens, 3 into 16, 48, total 100. 100 is giving how much carbon dioxide? 1 mole. 1 mole means its gram molecular weight. Gram molecular weight is 44 grams. What is 1 mole CaCO3? 100 grams. Its gram molecular weight. Same problem, I do a little change and give. Find the weight of CO2 form.
Yes.
Find the weight of CO2 formed When 10 grams of 90% pure, 10 grams of 90% pure CaCO3 is decomposed. So similar problem, only I change this part. First step is common, 100 is giving 44. Now in the second step, 10 grams of 90% pure gives how much? This is 9 grams. So 100 gives 44. 10 grams of 90% pure is 9 grams, gives how much? So 9 into 44 by 100. That will be the answer. Calculate the number of moles of oxygen evolved. Ninety 10 grams of 90% pure. So this zero, these are cancelled. 9 grams is remaining. 100 gives 44. 9 gives how much?
That's not.
10 grams of 90% pure means 10 into 90 by 100. That's the meaning. Now what is the question I am asking now? Number of moles of water evolved by the decomposition of one 225 grams of KClO3. Okay, immediately turn one page back, borrow this reaction of KClO3 decomposition. Do it fast. One page turn back and just copy down the reaction related to decomposition of KClO3. Is it there? KClO3 decomposition? There or not?
Yes.
So 2 KClO3 gives 2 KCl plus 3 O2. How many moles? Giving how many moles? Very good. 2 moles giving 3 moles. 2 moles means 2 into its molecular weight. What is the molecular weight? 39 plus 35.5 plus 48. So 122.5. 2 into 122.5 grams He is giving how many moles? 3 moles. No need of converting this into grams, because they asked the relation between mass mole relation. Now they are asking 1.225 grams gives how many moles? So 1.225 into 3 by 2 into 122.5. That is your answer. That many moles. Or what is the answer? How many moles? 0.01. Is it correct? 0.01, is it correct? I don't think it is correct. Three by two. 3 by 2 is 1.5. You said 0.01, 0.015 moles. Correct? To remove this decimal, I put 10 divided with 10 cube. This with 10. So decimals are gone now. This cancel. So 3 by 2 is 1.5 and this become 10 power minus 2 or 15 into 10 power minus 3 or 0.015. Write one more question. Calculate the volume of O2. Calculate the volume of O2. Release rate STP. Volume of O2 release rate STP. By the decomposition of 3.4 grams of By the decomposition of 3.4 grams of H2O2, hydrogen peroxide. So borrow the equation from previous page. What is H2O2 decomposition reaction? 2H2O2 gives now the relation is asked between this and this. How many moles of H2O2? 2 moles. He is giving how many moles of oxygen? 1 mole. 2 moles means its weight is 2 into 34 grams. Because H2 is 2, O2 is 32. Total 34. 2 into 34 grams gives how many moles of oxygen? 1 mole. 1 mole of any gas at STP occupies. Yesterday's lesson. Very good. 22.4 liters. At STP. Now here they are asking 3.4 grams. Give how much oxygen? So 3.4 into 22.4 by 2 into 34. This gives the final answer. It is mass volume relation. This problem is based on, or within brackets you can mention, this problem is based on mass volume relation. The previous problem is based on mass mole relation. The first 2 problems are based on mass relation. First and second, mass relation. Second one, mass mole relation. That is the third one, sorry. First 2 are mass. Third one is mass mole. Now the last one, mass volume relation. Next point, or next heading. Volume, sorry. Heading is combustion reactions. Combustion reactions. C plus O2, CO2. Carbon solid, O2 gas, CO2 gas. Methane combustion. Any hydrocarbon combustion. plus x plus y by 4 O2 gas gives XCO2 gas plus y by 2 H2O liquid. Any hydrocarbon combustion. This is combustion of sulfur. This is combustion of carbon monoxide. This is combustion of aluminium. For all combustion reactions, energy is released. They are all exothermic. So all these are exothermic. For all exothermic reactions, delta H is equal to negative. Write the first question on this. Find the volume of CO2 liberated. Find the volume of CO2 liberated when 10 liters of methane, is subjected to combustion. Is subjected to combustion. Means the question is based on the second equation mentioned here. This one. So again I take that reaction. CH4 gas plus O2 gas plus 2H2O liquid. So 2O2 gas. This is a balanced equation. In balanced equation you have to underline. The problem is based on these two, methane and carbon dioxide. So 1 mole methane give 1 mole CO2. Or you can say 1 volume give 1 volume.
Yes.
Gases can be expressed in moles or volumes. So here 1 volume or 1 mole. 1 volume, how much you have taken?
You got
10 liters. If it is 10 liters, obviously this is also 10 liters. So the answer is 10 liters. Or 1 mole means how many liters at STP? 22.4 liters. This also 1 mole means. So 22.4 liters will give 22.4 liters. 10 liters will give 10 liters. That is the problem. Next question. Or next heading. After combustion reactions, you write acid-base neutralization reactions. Acid-base neutralization. HCl plus NaOH. H2SO4 2NaOH Na2SO4 plus 2H2 H3PO4 plus 3NaOH Na3PO4 Now first acid HCl is called a monobasic acid. It is called monobasic. It requires 2 moles of base. That's why it is called a dibasic acid. This H3PO4 require how many moles of base? 3 moles. That's why it is called a tribasic acid. So here monobasic, dibasic, tribasic. Monobasic acids means they can only react with 1 mole of base, or they give 1 mole of H plus ions. Dibasic acids produce 2 moles of H plus ions, or they react with 2 moles of base. Tribasic acids, they produce 3 moles of H plus ions, or they react with 3 moles of NaOH or base. Find the equivalent weight. Find the equivalent weight of HCl, H2SO4, H3PO4. Find the equivalent weight of HCl, H2SO4, H3PO4. So equivalent weight of an acid is equal to molecular weight by basicity.
Yes, I think so.
That is equal to molecular weight by number of
What is it?
replaceable
What is it? What? And second shift.
H atoms equivalent weight by 3. 3 plus 31 plus 64. So how to determine the equivalent weight of an acid? Its molecular weight by number of replaceable hydrogen atoms in the form of H plus ions. That is called basicity. The basicity of orthoboric acid is option A, m by 1, m by 2, m by 3, m by 2.5. Very good. Option A is right. Right, but the formula contains 3 hydrogens. We are tempted to answer option C. Generally, by seeing the formula, we go for option C. But why it is option 1, m by 1? Write the reason. Orthoboric acid is not a Bronsted acid. It is not a Bronsted acid. Bronsted, yes. Proton donor. But a Lewis acid electron pair acceptor. When you look at orthoboric acid, which is BOH thrice, H3BO3 is nothing but BOH thrice. Here boron has a vacant orbital. So when you dissolve it in water, the water molecule donates an electron pair This is electron pair donor. Means Lewis base. This is electron pair acceptor. It is a Lewis acid. So then it results in BOH thrice. It is linked to water and O carries plus. Why O carries plus? Because it has donated an electron pair. To become O neutral, one hydrogen gives back its bonded pair and become BOH 4 times total minus plus H plus. Now you take 10 minutes break and freely don't sit. You have to sit only. Some rule is there. So why I am giving break? Because immediately after breakfast you are sitting here. You will have some lethargy. So move your body, lethargy should go out, you should be active, then again we start. Okay, is it okay?
Feel out.
Okay.
By the way, Hitler's name is Adolf Hitler, not Rudolf Hitler. His name is Rudolf, not Adolf.
Oh, okay. Corrected, thank you. Why the orthoboric acid? Why it is not tribasic. Though 3 protons are there in the formula, H3BO3. There are 3 protons, but still it is monobasic, because the reason is it is not a proton donor. Proton donors are called Bronsted acids, but it is an electron pair acceptor. Because look at the central boron. Who is our engineer? Network engineer? So look at the boron. How many bonds it has? 3 bonds. BOH thrice. Bond means 2 electrons.
Same.
3 bonds means how many electrons? 6 electrons. 6 electrons means its octet is not complete. Only sextet is complete. What is? Sextet is complete. Sextet means 6 electrons. Octet means 8 electrons. So the central boron in BOH thrice is electron deficient.
You.
What type of molecules are called electron deficient molecules? Please write a point. Molecules in which
Yeah.
the central atom, molecules in which the central atom has less number of electrons.
Hard one.
Has less number of electrons than
Yes, hard.
required for, not than octet of electrons. Than octet, OCTET, octet. So molecules in which the central atom has less number of electrons than octet of electrons are called as electron deficient molecules. Electron deficient molecules. These electron deficient molecules, electron deficient molecules always act as Lewis acids. They act as Lewis acids. They act as Lewis acids. Here I will ask you one more question. These Lewis acids in organic chemistry we call as electrophiles. So Lewis acids are electrophiles. And one correction from my side, our doctor indicated, what is your name? Perman. So Perman said it is not Rudolf Hitler, it is Adolf Hitler. So correction. So you are no longer a Hitler.
Yes, I am.
It is Adolf Hitler, not Rudolf, the actual name, corrected by our Perman. And second, one more point, and one more doctor, what is your name? Please stand up. Rocky. ROCKY.
Rakipul. Adi. Yeah, you. Yeah. You. Rakipul. You.
Continuation. So we shortcut. Dr. Rocky. Sit down, sit down. So what he is telling, my mole concept is weak. What shall I do? He openly asked, but many students
Said weak.
might not be asking this one. Somewhere? Okay. So maybe some of you might not have expressed it. Dr. Rocky Bull has expressed it. Mole concept, very simple. Mole is an entity.
So out.
It is equal to gram molecular weight or gram molecular weight is equal to mole. It is equal to gram atomic weight. It is also equal to gram formula weight.
Yeah.
It is also equal to NA, structural units. It is also equal to 22.4 liters at STP. If the given substance is in gaseous state, so students should know this. Mole can be equated in different forms. Mole is equal to gram molecular weight, or mole can be equal to gram atomic weight, or mole can be equal to gram formula weight, or mole can be equal to Avogadro number of structural units, or mole can be equal to some volume, 22.4 liters, if the given substance is in gas form or gaseous state. That's all. So this is a broader sketch in your brain. Here, gram molecular weight is also called gram mole. Gram atomic weight is also called gram atom. Student, if he knows this, and these are all interconvertible, one can be converted into other. All these parameters are interconvertible. I can take gram molecular weight, convert into atoms, or I can take gram molecular weight, convert into volume. All are interconvertible. So this is broadly mole concept. Mole is a big entity which contains huge number of structural units, 6.022 into 10 power 23 structural units. There is a question we'll ask our what is the name?
As agent.
Rocky Bull. We'll ask a question. Suppose his father gave him 1 mole of rupees on his birthday, and he is given power to spend 1 million per day. 10 lakhs rupees he can spend.
Big.
Father gave him 1 mole of rupees with him. In how many days Rocky Bull will spend the entire amount.
Office. Like cartoons.
How many rupees he has? 6.022 into 10 power 23 rupees. Per day, how much he spends? 1 million, 10 lakhs rupees. See, rupees 6.022 into so 10 power 6 rupees, which is 1 million. In one day he can spend. But he has how many rupees? 6 into 10 power 23 rupees. In how many days he can spend? So 6 into 10 power 23 by 10 power 6. 6.022 I approximately taken as 6. So 6 into 10 power 17 days. Now 365 days is 1 year. He has how many days to spend? 10 power 17 days equal to how many years? 6 into 10 power 17 by 365. Let us approximately take 360. Just approximation I am taking 360 so that I can cancel this in 60, 1 by 60. So 1 by 60 into 10 power 17 or 1 by 6 into 10 power 16. 1 by 6 is 0.16 into 10 power 16 or 1.6 into 10 power 15 years. Correct? So, Mr. Rocky Bull require 1.6 into like this, like this, like this. How many zeros? 15 zeros. That many years he required to spend the entire award number of rupees. So actually why this calculation? Means the student should know this Avogadro number is a very big number. That he should understand. If any substance contains Avogadro number of particles, it is called 1 mole. The Avogadro number of particles, the substance if it is containing, it is equal to 1 mole. Or Avogadro number of particles mass is 1 mole. So these are all interconvertible things. Student can have hands-on experience on mole concept if you start doing problems given in your textbook backside, in-text questions, practice questions. Actually the mode they created is self-learning. You are actually, luckily you are having very good program. Generally what we do in other normal courses, we dump, teacher come and dump. Because I have a lot of things in my mind, I can dump years together. So much of material I can dump in my brain. So dumping itself can't give you that much knowledge. When you yourself involve and start doing and asking doubts with the fellow students or the teacher, then you are really learning. So that real learning environment, that type of format is created here. So in general, I should not tell the Fiji, Ellen, Akash, Narayana, Sri Chaitanya. I worked in all these. I worked in Fiji, Delhi. So most of the institutions we worked long back. I told you yesterday one result. First rank to 25 rank. All gone to our school. So like that, we worked with many institutions. So 1 to 25 ranks also, why they got? Because they have given freedom. Correct? So you are given freedom. So you should involve and solve on your own. Many students also ask, sir, IUPAC names I am confused. IUPAC names, IUPAC is a governing body. They have given a set of rules. You or me or X, Y, Z in the entire world, international union it is. Each country cannot name in one same compound, in India one name, or in our Shillong one name, Hyderabad one name, every city or every country has one name. There is a lot of total confusion. That's why IUPAC has given certain guidelines for naming organic compounds or complexes, coordination compounds. Everybody has to follow. So once we go through the rules, we practice. Like that FE. In common system we call iron carbonyl. Iron carbonyl. What is the oxidation number of iron here? Very good, 0. In all metal carbonyls, metals have 0 oxidation state. So its IUPAC name, pentacarbonyl, 5 ligands are there. Pentacarbonyl, iron, within square bracket you have to mention its oxidation number. That is 0. So its IUPAC name is pentacarbonyl, iron 0. Who said it? IUPAC has said it. We are following it. So, IUPAC names you become proficient when you start practicing 20 names. You write 20 names, write the related structures. Or write 20 structures, write the names. Name given, structure write. Or structure is given, write the name. If you do crisscross, this way, within 2-3 days you will be proficient in IUPAC system. It is not a Herculean task. Rather, the very entrance into a medical college, once you enter into medical college, then the real hard work starts. Because medicine involves human physiology, anatomy, biochemistry, community medicine, pharmacology, pharmacognosy, lot of subjects. Biochemistry, lot of subjects. Each subject is bulky in nature. So medical students looks very glamorous, wearing an apron with a stud on your shoulder, around your shoulder. Looks very glamorous. But glamour is one part. Behind there is another big part. They can't attend marriages, they can't attend functions. Every time, lot of books. Like that, you have to study 5 years. 5 years syllabus you have to write NEET PG. Now you are going to write NEET UG. After your NEET UG, acquiring your medical degree, after internship and all, then you are allowed to write NEET UG exam. Not NEET UG, PG exam, post graduation. Very limited number of seats. radiology. In entire this Meghalaya, maybe 3 seats or 2 seats will be there. Radiology, which is top branch. Any medical student after medicine, he wanted to become a radiologist. Top sort of a branch. Radiology, pediatrics, orthopedics, cardiology, general surgery, general physician. These are all top branches. Of course, female also opt for gynec. Female students, they opt for gynecology also. So these branches are very limited in number, and number of doctors, 1 lakh doctors come into the market every year, and these 1 lakh students are appearing for NEET PG exam. Their syllabus is 5 years of your medicine. Again you have to consolidate 5 years subjects, prepare notes, bits, so much of work. Then you enter into NEET PG. Okay, luckily God has given you NEET UG, NEET PG. Next what? Next also you have to struggle a lot to do super speciality. After that what? Every day you have to see the journals of medicine, because medicine is keep on changing.
No.
For example, you take aspirin, analgesic, acetyl derivative of salicylic acid. What is aspirin? It is in your syllabus. So it is a painkiller, pain reliever. Suppose severe headache is there, doctor asks you to take an aspirin. Now immediately, miraculously, your headache, somebody has taken away. That much free you will become within few minutes. So though it was discovered for pain relieving, later scientists came to know it is not only a pain reliever, but also makes the blood thin, blood thinner. Actually, when blood becomes thick, more viscous, it develops clots, blood clots. Blood clots in the brain region cause paralytic strokes. Blood clots in the heart region, veins or arteries, heart attacks. So to prevent blood clots, either in the brain region or heart region, so WHO, World Health Organization, recommends those who cross 50 years of age, they can take 75 milligrams of aspirin per day to make the blood less viscous, more thin. But the problem with aspirin is, it is an acid, COOH group is there. COOH group is called carboxylic acid group. That's why it should not be taken in empty stomach. It increases the acidity. After taking food only you have to take this. And one more recent discovery, aspirin should not be taken as prescribed earlier, every day 75 milligrams. It makes blood too thin. Sometimes blood vessels will break because the blood becomes too thin. Blood vessels break. That causes internal bleeding and a life-threatening situation. So aspirin should be cautiously used nowadays. Earlier, 5-6 years back, it is profusely used. So why I am telling this aspirin case, medicine is keep on changing. New discoveries are coming. So doctors should be updated. No sir, I studied my MBBS, MD, super speciality. Now let patients come, I will treat. No, nobody will come to you. Only if you are an updated doctor and keep on updating yourself, then only you will be successful. So these are all the challenges for the medical profession. But of course, when you study medicine, the discipline, the hard work, automatically learn, and ultimately you will become like a totally isolated person. Generally doctors go and mingle with public. They are generally in isolated condition. Public life is less. Because they have a lot of pressure. They have to update themselves. So it is a very tough job to do. You have to logically decide what is the actual disease. So many things are there. So, but I asked the same question to many of my students who are not top doctors nowadays throughout the world. Throughout the world. In the last 30 years we produced many students as doctors. They themselves become doctors, not we produce. We taught them, that's all. So when I ask Raghuram, because he is in Hyderabad, no sir, I am interested in this profession, that's why I came into this profession. Of study. Okay. Somebody asked me, what is the spelling of Bronsted? So actually Bronsted-Lowry theory, acid-base theory, it is in your 11th class. Ionic and chemical equilibrium, one chapter is there. In that ionic equilibrium, you have acids, bases, Bronsted theory, Lewis theory, Arrhenius theory, pH, problems related to pH, buffer solutions. So big chapter it is. Maybe at that time you may not feel well, or your teacher might not taught you interestingly. Many factors are there. Nothing wrong. But in this coming, let us say next 2025, May 5th or 7th, it will be your NEET 2025 exam. May 5th or 4th? 4th. 4th May 2025. Now today is August 1st. So August, September, October, November, December, January, February, March, April. 9 months time is there. Ample time. You can create wonders. You can totally grind the entire subject, drink it, swallow it, keep it in your brain. Not a big task, very easy task. But every day in a disciplined way, things must be rolling on. You should be revising. I told you, do have a discussion, healthy discussion of asking questions. Of course, some enjoyment, just like you are crying and shouting, that also gives you some energy, no doubt. Because student has so much hidden energy. You want to express it by loudly crying or pushing the other student down into some form. Don't push person into valley. So multiple fractures will be there. So some enjoyment should be there, I am not denying it. At the same time, a very big task in 9 months of time. So slowly you progress. It is an easy task. Definitely you all will be coming with flying colors. That is a positive thing for your family, your friends, your relations, the institution. So total, your state. Suppose let us assume that some of you have cracked 720 out of 720 in 2025 NEET. That will create a wonder from Meghalaya, which is a northeastern state. Generally, northeastern states, we say very backward. Though you are not backward, that is imprinted here. Some insurgency problems are there. Insurgency, I think in Meghalaya it is not there. But in Assam, Nagaland, there is so much of insurgency. Some people are fighting with our own army, Indian army is fighting. So insurgency is there, development is not there. Some border countries intrusions will be there. So much of disturbances are there. That's why we categorize these very backward. Even Bihar also gets very backward. UP is just progressing. Otherwise it is also very backward. Because the British influence is not much here. Britishers ruled most part in Bombay presidency, Madras presidency. So they occupied the seashores. Because Britishers are good at sea. They are good at navy. So they choose naval places for their free movement. That's why they developed those Bombay and Madras, Machilipatnam, some all port areas. So in one way they looted our money. Of course, that developed the railway system, this and that, postal departments. So that's why people also become talented. When somebody is looting, you will be very careful and take some preventive measures. That's why people also develop intelligence to prevent this looting and all.
Right.
Okay. That is all history. We don't require it. Why I am telling all this? Any student, don't feel inferior. Everybody is potential. It is within you to manifest it, the potentiality. So, you always feel that you are very strong, physically, mentally. And with a positive attitude, you always think that you are going to crack the NEET 2025. With that, the only thing you require to do is continuous revision in regular intervals. After 4 months, if I again ask you, what is the basicity of orthoboric acid? You should not say 3. It is 1. Okay. I think we have discussed some combustion reactions.
Yep.
Combustion of hydrocarbon, carbon, sulfur, some combustions. Correct? Now write the next heading. Precipitation ionic reactions.
Yeah.
Precipitation ionic reactions. AgNO3 aqueous arrow downwards indicate a solid is separated. Whenever in a chemical reaction a solid substance is separated, we call it as a precipitate.
Yep.
Barium chloride, aqueous, plus sodium sulfate, aqueous. Barium sulfate, plus 2 NaCl. Here I take a pause and I also tell about the importance of barium sulfate. If you take the second group sulfates, beryllium sulfate, magnesium sulfate, calcium sulfate, strontium sulfate, barium sulfate. The solubility of the sulfates decreases. Solubility in water decreases down the group. I think this is the question asked in one of your mock tests. Maybe first mock test this question was there. Why the solubility of sulfates of second group decrease down the group? Solubility of any compound in a particular group is decided by two factors. One is called lattice energy, the other is called hydration energy. So write that point. Solubility depends on number one, lattice energy. And number two, hydration energy. If lattice energy is greater than hydration energy, if lattice energy is greater than symbol also you can use, hydration energy, the solubility of the compounds decreases. The next point is, if hydration energy is greater than lattice energy, the solubility of a compound increases. The solubility of a compound increases. So it all depends on two factors. One is lattice energy, to break the lattice. Once it is broken, the ions are surrounded by water molecules. Whenever a particular ion is surrounded by water molecules, we call it as hydrated. And the energy released is called hydration energy. So how many factors decide or govern the solubility of a compound? Two factors. One is the energy required to break the lattice, that is called lattice energy. The other is when the ions are surrounded by water molecules, the energy released is called hydration energy. If lattice energy is more dominating than hydration energy, means the lattice cannot be broken, means the compound become less soluble or even become insoluble. If hydration energy is more dominating, then the energy released break the lattice and the compound become more soluble. So in second group sulfates, why top to bottom the solubility is decreasing? because lattice energy becomes more and more dominant than hydration energy. Now the doctors use a test called barium meal test. In barium meal test, the person is asked to swallow few ml of barium sulfate into the stomach. So he will drink that suspension of barium sulfate. Barium sulfate goes into the stomach. The stomach HCl cannot break it. It is insoluble. So it remains as an insoluble solid in the stomach also. Then doctor will send X-rays through the stomach. Now these X-rays, when they are passing through the stomach, this barium sulfate, which is already swallowed, which is in the insoluble form, it will scatter the X-rays. When X-rays are more scattered, you will get a more clear picture of the stomach. That is called barium meal test. So the barium meal test is based on the principle of insolubility of barium sulfate in the stomach. Even today, it is a viable test. Doctors are, though there are gastroendoscopy, a very sophisticated test, in which doctor gastroenterologist will introduce a tube having a bulb in the edge, one of the terminal part. The tube contains a bulb. The tube is swallowed by the patient. So the tube goes into the stomach. The tube is connected to a gastroendoscope. On the monitor, the endoscopist, gastroenterologist, will observe the changes in your stomach, whether any ulcers are there, whatever it is. So that is a deciding factor. So it becomes insoluble. This becomes more soluble. Now third equation, sodium phosphate plus barium chloride, you will get barium phosphate plus NaCl These are all precipitation ionic reactions. Fourth one, of lead chromate.
What's that?
What are all these? Precipitation ionic reactions. Precipitation ionic reactions. The number of moles of barium phosphate, the number of moles of barium phosphate formed formed when 0.1 mole of sodium phosphate react with 0.5 moles of 0.5 moles of barium chloride formed. Barium chloride, 0.5 moles of barium chloride in an aqueous solution. In an aqueous solution.
So,
So again we are writing the equation. Na3PO4 plus BaCl2. I think 3 BaCl2 gives rise to Ba3 P taken 0.1 mole. How much we have taken this one? This is how much? This is as per equation. As per balanced equation. These are given moles. These are given. Now 2 moles are reacting with 3 moles as per the balanced equation. 0.1 mole react with how much? 0.1 into 3 by 2. Correct? How much it is? 2 moles are reacting with 3 moles. 0.1 mole should react with how much? Yes, how much it is? Do fast. 0.3 by 2 means 0.15. So only 0.15 moles react. But how much we have taken? 0.5. How much is left behind? You have taken 0.5 mole. How much is reacting? How much is remaining? Point? So the reactant which is left excess is called excess reagent. The reactant which is completely used up is called a limiting reagent. So in this reaction, what is the limiting reagent? NaCl, because it is 0.1 mole completely used up. What is the excess reagent? Barium. Oh, it is gone. Luckily we have a backup. Board is there. Chalks are there. No, marker is not working, no. Here in this?
Just try. Mother. Just try with this one, it's unrecorded. That's fine.
So we are taking which reaction? NaCl or Na3PO4 plus gives rise to barium phosphate plus NaCl. We have balanced this with 3 and this with 2, this with 6. So as per balanced equation, 2 moles this react with 3 moles to form 1 mole of this and 6 moles of this. That is as per the balanced equation. Balanced equations are called stoichiometric equations. Now we require these 3 only. The question is based on these 3. So as per the balanced equation, 2 moles are reacting with 3 moles. 2-3 ratio. But how many moles they have taken? 0.1 mole of NaCl, Na3PO4 they have taken. How much barium chloride it react? So 0.1 into 3 by 2. So 0.3 by 2. Correct? So it is 0.15 moles of BaCl2. But how much BaCl2 we have taken? 0.5 moles of BaCl2 we have taken. Of which only how much is reacting? 0.15 moles reacts. So original minus reacted is left. So it is how much? 0.35 moles left. The reagent that is left is called excess reagent. So this is excess reagent. The one that completely reacts is called a limiting reagent. Right, a very important point. The quantity of the product, is always decided by decided by the limiting reagent. To understand this, I will give a very beautiful example. Many textbooks also indicate this example. Very easy, student will easily understand. Let us say a bike manufacturing unit was there. Honda bikes it is making, or Suzuki bikes, whatever it is. In the bike manufacturing unit, let us say every day 1,000 bike frames are made, 1,000 front wheels, 1,000 back wheels, 1,000 seats, 1,000 engines. But there is a problem in the handle manufacturing unit. Only let us say 500 handles are made there, but all the remaining 1,000. The bikes are all assembled. Only they are waiting for handles. How many handles they got from handle section? 500. How many completed bikes will roll out from the factory?
Back 100.
500. Here the smallest number determines the product quantity. That's why it is called a limiting reagent. So the limiting reagent always decides the quantity of the product. Here what is the limiting reagent?
Okay.
Sodium phosphate. How many moles it is?
It's just the one.
How many moles we have taken? 0.1 mole. If 2 moles are reacting, you are getting 1 mole. 2 moles, 1 mole. If it is 0.1, how much?
And they are all something. Yes.
So 2 moles are giving 1 mole. 0.1 mole gives how much?
Yes. What's the
0.1 by 2. 0.05. This is the answer. Answer is 0.05 moles. A very standard question they are asking this. So hope you understand what is limiting reagent, what is excess reagent, who decides the fate of the product. Limiting reagent decides the fate of the product, not the excess reagent.
Yeah.
Now I have given some inputs. I have given certain precipitation reactions, certain acid-base neutralization reactions, certain decomposition reactions. Also write some redox reactions. We will also give a small list of redox reactions. So write the heading, redox reactions.
Was
CuO plus NH3. Cu plus N2 plus H2. 2 NH3, 3 H2O, 3 CuO, 3 C. Here copper is in +2. Here it is in 0. Decrease in oxidation number. It is called a reduction.
best.
Here nitrogen is in -3 state. Here it is 0 state. -3 to 0 increase in oxidation number. It is called oxidation.
So,
Oxidation and reduction both occur simultaneously. That's why the reactions are called redox reactions. Now KMnO4 plus H2SO4 plus H2C2O4, which is called oxalic acid. This is permanganate versus oxalic acid. It gives K2SO4 plus MnSO4 plus H2O plus CO. If you balance this, 2 KMnO4, 2 MnSO4, S4s become 3, 3H2SO4, CO2, 5H2C2O4, 10 CO2, and H2Os become 10 plus 6, 8. 8 H2. This balanced equation. In the balanced equation, Mn here plus 7, here it is plus 2, plus 7 to plus 2,
some.
reduction. Here carbon is plus 3,
Really sharp.
here carbon is plus 4. This is oxidation. This is so important. Students should know, even if I wake him up in the early morning 2 o'clock, wake him up, and what is the relation of different number of moles in permanganate versus oxalic acid in acidic medium. If I ask that, he should know 2 moles of KMnO4 is identically equal to 5 moles of H2C2O4, which is identically equal to 10 moles of CO2. If you know this line, you can solve many problems. That much important. Once I say important, you put a star mark. Obviously it is important, no doubt in that. Actually, this you also work out in your volumetric analysis. You have done it in your lab. Suppose I create a problem like this. 10 moles of potassium permanganate. 10 moles of potassium permanganate react with 20 moles of oxalic acid in sulfuric acid medium. In sulfuric acid medium, the number of moles of CO2 produced is the number of moles of CO2 produced is so what is the relation? 2:5. But here how much I have taken? 10 moles. This I have taken as 20 moles. And this is question mark, we have to find out. So when 2 reacting with 5, 10 react with how much? 10 into 5 by 2. 25. But only 20 are there. So this is not the way to find out the reverse. 5 react with 5 moles permanganate, 5 moles oxalic acid, 5 moles H2C2O4 react with 2 moles KMnO4. This I am erasing. I am taking the reverse. 5 react with 2. How much I have taken? 20. React with how much KMnO4? 20 into 2 by 5. 8 moles. Correct? But we have taken 10 moles. How many moles will react? 8 moles. How many moles will be left? This is excess reagent. This is limiting reagent. This will decide the fate of the product. Do you understand, or shall I repeat? Very good. I can repeat hundreds of times, don't worry. As per the equation, 5 moles of oxalic acid react with how many moles of permanganate? So here I am writing the same. 5 moles of H2C2O4 is reacting with 2 moles of
It's same.
KMNO4. Clear? Any doubt in this? No. But how much we have taken? 20 moles. React with how many moles?
One.
This 20 into 2 by 5. 8 moles will react. But we have taken how many moles? So 10 moles taken. But just now we have calculated 8 moles will react.
That's
2 moles will be left.
anything.
Then it is called excess reagent.
This.
Excess reagent is waste. It won't decide the fate of the product. Which will decide the fate of the product? When it is become excess, it is automatically become limiting. So now, as per the equation, 5 moles are giving 10 moles. 5 moles of H2C2O4 is giving how many moles? 10 moles CO2. 20 moles give how much? So 20 into 10 by 5. 40. This is the answer.
What?
Because this is a limiting reagent. Limiting reagent only decides the quantity of the product. Limiting reagent only decides the quantity of the product. Now students should solve many problems like this. So we have redox reactions, acid-base neutralizations, precipitations, combustions, decompositions. In all these varieties, you have to solve many problems. Okay, shall I conclude?
Sure.
Thank you very much.
So